Hi guys, today we're going to talk about quotient of powers. Quotient means to divide. So when you're finding a quotient, you are dividing. It says, the notes say, when dividing the same base. So remember, this is your base, this is your exponent. When dividing the same base. So in other words, you have a fraction and you have the same base on top that you do on bottom. Look to see whether the bigger positive exponent is on the top or on the bottom, and that's where the variable will be left over. I'm going to explain that to you. Expand the exponent in your head and then cancel out any that match. Like for instance, when you have an x over an x, that gives you 1. Or you have an A over an A, that would give you 1, or 1 over 1, because you know A goes into A once, A goes into A once. That would leave 1 over 1 or 1. Okay, so here we go. Here's an example. We have x to the 6th over x to the 2nd. Expand that in your head. X to the 6th means x times x times x times x times x times x, 6 of them. And x to the 2nd power means x times x. So when you cancel an x for an x, which actually gives you 1 over 1, and you cancel x for an x, which gives you 1 over 1, those x's cancel. You have x to the 4th power left, and they're in the top of the fraction. So it would be x to the 4th power over 1, or just x to the 4th power. See? You have more of them in the top than you did in the bottom. Okay, the next one we're going to do, we have some y's. We have y to the 3rd over y to the 7th. So if you expand that in your head, then y to the 3rd is y times y times y over y to the 7th is 7 of them. And when you cancel a y for a y, that's the same as having 1 over 1. Cancel a y for a y, 1 over 1. Cancel a y for a y. You end up getting 1 over y to the 4th power because you have more of them in the bottom. So you're going to have them left over in the bottom. Okay, so here's one. We have a to the 9th over a to the 4th. If I expanded that, I would have 9 a's on top, 4 a's on the bottom. So in my mind, what I always say to myself is, then the 4 a's in the bottom cancel out 4 of the a's in the top, and I have a to the 5th left in the top. I would have a 1 left in the bottom, but a to the 5th over 1 is simply a to the 5th, and that's it. Okay, next one, b to the 2nd over b to the 5th. So I have more of them in the bottom, so they're going to be left over in the bottom. And really all I want to know is how many more would I have left in the bottom? Well, the 2 b's in the top cancel out 2 b's in the bottom. So I would have 3 b's left in the bottom. That would be b to the 3rd. And since everything in the top is gone, I would have 1 over b to the 3rd. That's it. Okay, x to the 2nd over x to the 7th. The 2 x's in the top cancel out 2 x's in the bottom. That would leave me with x to the 5th in the bottom. I'd have 5 x's left in the bottom. Now let's do the y's. The y, there's only one y in the bottom. That's y to the 1st. Cancels out one of the y's in the top. That would leave y to the 2nd in the top. I'd have 2 y's left. They'd be in the top. Z to the 4th over z to the 4th, they just cancel, and that's all. And I really don't need that big long divide sign anymore. Okay, the next one, we have b over b. That's b to the 1st over b to the 1st. They just cancel each other out. That's 1 over 1. So they cancel out. The 5 c's in the top cancel out 5 c's in the bottom. So I will have 3 c's left in the bottom. That would be c to the 3rd. The 2 d's in the top cancel out 2 of the d's in the bottom. So I have one D left in the bottom. You can put D or you can put D to the first. But what's left in the top? A 1. Because remember, every time you cancel and you have a 1. Like B goes into B one time, B goes into B one time. You have a 1 left when you cancel. And that's it. The next topic is power of a power and power of a product. So here's an example. Well, first it says when raising an exponent to another exponent called a power, you have a power to a power, you multiply the exponents together. So anytime you have a power to a power, that sounds pretty powerful to me. Multiplying is pretty powerful. So you're going to multiply them. And what does it really mean if you take something to the fourth power? That means take it times itself 4 times. So we'd have x squared y to the third times itself 4 times. And then we would end up adding 2 plus 2 plus 2 plus 2. That would give us x to the 2, 4, 6, 8. That would give us x to the 8th. And y to the third times y to the third times y to the third times y to the third. We would add our exponents. That would be 3 plus 3 plus 3 plus 3. That would be y to the 12th. And so the long story short, when you have a power to a power, you multiply your powers. So here we have a to the fourth to the second power. So a to the 4 times 2 is 8, a to the eighth. B to the fifth time to b to the second power, that would be b to the 5 times 2. 5 times 2 is 10. And then this is a c to the first. So we have c to the first to the second power. You multiply your powers. That would be 1 times 2. That would be 2. That's it. Okay. When you have a whole number, like in the next one, you do 3 to the first to the second. You multiply your powers. So that would give you 3 to the second power. 3 times 3 is 9. And then this is a to the first to the second power. 1 times 2 is 2. So we would get 9a squared. Or maybe an easier way to think of that really would just be 3 to the second power times a to the second power. And 3 to the second power is 9, so we would get 9a squared. Okay, the next one. So we're going to do the same thing. We're going to do 4 to the second power. 4 to the second power is 16. Then we're going to do x to the first. X to the first to the second power. Multiply your powers. When you have a power to a power, that's pretty powerful. So multiply. So x to the second. Then we have y to the second to the second. We multiply the power, we get y to the fourth power. Okay, last one. Last one we have, oh, this one's a little more involved, not much. We're going to take 2 to the fourth power. You may need your calculator for that. You would just type in 2 to the fourth power, and then your calculator will give you 16. 2 to the fourth power is 16. So we'd have 16. This is x to the first to the fourth. So 1 times 4 is 4. And then we're going to take it times 3x to the second, y to the third. So we're going to take our 16 times our 3, just like normal numbers. 16 times 3. You can use your calculator. You're going to get 48. And then you're going to multiply your x to the fourth times your x to the second. So when you multiply like bases, our bases are alike, our bases are x's. You add your powers, so that would be x to the sixth, and there aren't any other y's. This is the only y, so we just get y to the third. And that does it. Have a great day. You're going to look for a Delta Math called Exponents Day 2.